Hello, and welcome to a continuation of the lecture on Python programming fundamentals. In this video, we'll be discussing functions as well as some more general features of Python syntax. A function in programming is very similar to a function in algebra. Let's briefly consider what a function in algebra is like. I will write some what's called LaTeX to illustrate a mathematical function. So here I have the function f of x equals 3 times x plus 2. F is the name of my function, and it accepts an input called x. X is a variable. It could take on any value. And what this function will do is, given some x, it returns the value 3 times x plus 2. So, if I were to evaluate f of 6, this would evaluate to 3 times 6 plus 2, which is 20. Additionally, I could have some variable and if I were to evaluate the function on that variable, it would do the same thing. So if y is equal to 3, then f of y would be 3 times 3 plus 2, or 11. Effectively, this x is a placeholder for whatever value I apply f to. So if I apply f to 6, then 6 fills takes the place of this x when I'm evaluating the mathematical expression. Functions in programming work the same way. We define some function that accepts some input called arguments, and then it manipulates those arguments in some way, perhaps by doing mathematical computations, but perhaps by doing something more complicated, and then it returns a result. Let's look at a function in Python. Here we've defined a very simple function that will square a number. The function definition begins with the def keyword. Def, unsurprisingly, stands for define. After that, we have a space and then the name of the function. We've given this function a descriptive name. Since this function will square a number, we've called this function square. We should get in the habit of giving functions and variables descriptive names. Just like it's a good idea to include comments in your code to document what you're thinking as you're writing that code, or what you intend for that code to do, it's a good idea to give functions and variables meaningful names or descriptive names so that when we're reading our code, it's very easy to understand what it does. A major part of getting good at programming or becoming a competent programmer is simply developing the habits that allow you to be able to easily collaborate with others or yourself in the future when you no longer remember exactly what you were trying to do. Descriptive names are very important when trying to debug code or think through a complicated problem. So we've named this function square, and then we have parentheses. And in the parentheses goes the argument of the function. The argument is a placeholder that stands for some input that the function will receive. Then we have a colon to signify the end of the defining line. Under that, we have the body of the function. The body of the function is where we define the function's purpose. This function is very simple. It simply returns number, whatever the input is, raised to the second power. Note that the body of the function is indented. This return statement will terminate the function, and no code placed after it in the body will run. So let's go ahead and evaluate this cell, which defines the function. The name square is now defined, and square is a function. So if we evaluate square, we see Python tells us square is a function. Now that square is defined, we can apply that function to various inputs. In programming, applying a function to some input is called calling the function, or we're making a function call. Let's see that in action. We can apply the function to numerical input like 5.5, or we can call the function on Python variables. So we could also assign a variable to some number, assign some number to a variable rather, and call the function on that variable. So if we evaluate this, we should get squared should equal the result of squaring 5.5, and then we'll also print out the result of squaring 6. So the squared variable now has the value of 30.25, the result of squaring 5.5. Meanwhile, we also printed out the square of my number, which is 36. Note that this is all a straightforward analogy of what we began our discussion with in terms of algebra. Now, for those of you who were remembering the variables video, when I was discussing types of variables, and if you know about other strongly typed programming languages, you might be wondering what happens if number is not a number. After all, number is a placeholder variable in this function definition. We discussed in the last video that variables in Python can be of any type. So what happens if we don't put a number here, but instead put text or something else? Whenever we're wondering something like that, it's a great idea to simply try it as an experiment. So we'll do that. We'll try and print the square of banana. And what happens is we hit an error, a type error. And if we look at the error message, it says unsupported operand type for double star or power. POW is short for power. And these two things are the same. And it says that we can't use this power operand between string and int. In other words, we can't raise the word banana to the second power. That doesn't make any sense. And more important than it not making sense, it's not defined in Python. In addition, the error message gives us something called traceback, which shows us where the error was encountered in the code. When we tried to print out the square of banana, square, the function call, eventually executed this line, where we tried to take number and raise it to the second power. When we called square on banana, number takes on the value banana. And we can't raise banana to the second power. That doesn't make any sense. Hence why we encountered a type error. There's a lot of useful information in this error message. When you encounter errors, don't panic. Don't give up. Read the error message and use it to figure out what's happening in your code, and try and fix the problem if possible. You can also use this error message to communicate to others what kind of problems you're having and see if they can help you. I'm trying to suggest that you shouldn't you think of error messages as indicating that something is wrong and broken, but just that something needs debugging. And you can use the error message. The error message is very useful for helping you debug your code or develop some better solution. We'll continue to talk about errors like this one and talk about how to debug code in future videos. I'd like for you to pause the video now and complete the following exercises. Using the square function as an example, write a function that will cube a number. When you're done with that, remember or review in the first video. Towards the end, I showed you an example of string interpolation. Use that example to write a say hello function, which takes in a name as an argument and then prints out hello name. An example of a function call would be say hello Zach, which should print hello Zach. So pause the video and complete these two exercises. When you've completed them, unpause the video and I'll share my solutions. Okay, so hopefully you've completed these exercises. Taking the squared function or square function as an example, we'll define a new function called cube. And cube will also accept a number as an argument. We'll return that number raised to the third power for the cube. Whenever we're defining a function, it's a good idea to test that it's working. A simple test is to simply call the function on some input where we know the answer. The cube of 3 is 27. And if we evaluate cube of 3, we see the result 27. Often in the lecture notebooks, and especially in the assignments, we'll include what are called assertions to test various bits of your solutions or code that we've written. Assertions are special statements that express some condition that may be true or false. If the condition is true, nothing happens when we run the code. If the condition is false, then an error is raised when we run the code. So for example, we can assert that the cube of 3 is equal to 27. Notice to check that these things are equal, I use a double equal sign. A single equal sign is used for assignment. A double equal sign is used for a comparison that two things are equal. Since the cube of 3 is 27, when I run this cell, nothing happens. There's no output. We can see the cell is run because over here, this blank bracket for an empty cell filled with a number. If I were to assert that the cube of 3 equals 26, which it doesn't, I would get an assertion error, letting me know that this condition was false. You may encounter this in the assignments, for example, when working on a solution. We may have an assertion to check whether your solution is working the way that we expect it to. And this may help you check whether or not you're on the right track. To solve the second exercise, we'll define the say hello function, which accepts a name as an argument. This function won't return anything. We'll simply print something out. And we'll print out hello placeholder, and then into the placeholder we'll put the name by using the format method. Now that we've defined this function, we can go ahead and call it and give it a string as input. Before moving on, I want to comment a little bit more on how arguments work. Notice that this function has the same argument as the square function. These arguments are not related to each other. Again, they're just placeholders for input to the function. In fact, arguments only have meaning within the function that they are a part of. So they only have meaning within the function definition. This concept is referred to as scope. Scope is the part of the code over which a name has meaning. Furthermore, we can see from when we use the square function that an argument that we can pass variables to a function, and those variables don't have to have the same name as the argument. In fact, they don't have to have a name at all. We can simply pass in values. Similarly, if we were to define a variable called number, it's totally unrelated to anything happening in the functions. If we call the function on a different value, it doesn't change the value of number. Again, this is because of scope. Number as an argument is scoped to the function in which it's defined and has no impact on the name number anywhere else in the code. This is a tricky concept that it takes some getting used to, but I wanted to emphasize it now so that we can build upon the idea in the future, and it will be somewhat familiar when we revisit it later on. So why do we go through the bother of defining functions? Functions help us in a number of ways. One, they help us respond to input, whether that input comes from a user, a file, or elsewhere in our code. Secondly, they help us organize our code in both conceptually into ideas or tasks, and it helps us organize our code for reuse. Let's see an example. Say I wanted to square the numbers 1 through 9, or apply some mathematical function to a bunch of numbers. So I can see the output if I print all of these. And we see the squares of 1 through 9 here. But maybe it turns out that I made a mistake and we didn't want to square the numbers, but we wanted to square the numbers and then add 2. Well, in order to do that, I would have to add 2 and add 2. And on each line of code, I would add 2 to every line. And I would have to type out +2 many times. This is clearly not very efficient and a little bit tedious. Let's see how the situation would be different if I were using a function. I could have a function called doIt that takes some argument x and prints out x squared. We see the same output as we got before. Now we realize our mistake and we realize we need not x squared but x squared plus 2. With a function, I only need to modify the code in the function definition rather than every line where I call it. And now we see the results of x squared plus 2. This saves us a lot of typing and a lot of work. Additionally, the functionality is packaged up into a conceptual unit with a name. This helps us organize our code into a hierarchy. A program is often a complex set of tasks and objects that relate to each other, composed of simpler objects and simpler tasks, and yet simpler objects and simpler tasks. By breaking out chunks of code into functions, we can give those simple tasks names so that the more complex tasks don't become overwhelming lists of simple or elementary operations. This idea is called modular programming. And again, we don't have anything in our materials explaining what modular programming is, so if you're interested in it, you should search for more information on the internet. There's a whole lengthy Wikipedia article about the idea of modular programming, its relationship with different languages, including Python, and its relationship to different ideas in computer science. I'd like for you now to pause the video and complete the following exercise. Instead of the doIt function printing out x squared plus 2, I'd like for you to modify this function so that it prints out the square of the value that it currently prints. So it should print x squared plus 2 quantity squared. Pause the video now and complete the exercise. Okay, if you've completed the exercise, you should have something like this. Print x squared plus 2. I simply wrapped that quantity in parentheses and squared that quantity. And we can see if we execute this cell and evaluate it on the input 1, we get 1 squared plus 2, which is 3, squared again, which is 9. I want to go a bit further from our discussion of functions to talk about Python syntax. I described that the function definition is structured in a particular way, where we have the def keyword, then the name of the function, then parentheses enclosing the arguments, followed by an indented body. Python uses certain elements or rules concerning how different symbols and words should be arranged to structure how the code is interpreted. This structure, or grammar, is called syntax. So to reiterate, to define a function, we must follow a particular syntax. A function definition begins with the def keyword. Why do I call it a keyword? Keywords are particular protected words in Python that have special function built into Python. Keywords are highlighted in green. So we can see def, print, and return are all keywords in Python. They do special things. When we're defining names, such as variables or functions, we should avoid using keywords as names. So for instance, if I were to create a variable, I might be tempted to name it type, and I might say type equals dog. But as I'm typing this in, I would see type is highlighted in green, and know that it's a protected keyword in Python. Reassigning keywords can interfere with the functioning of the Python interpreter and may cause the interpreter to behave in ways you don't expect, and may cause your code to execute kind of in a way that does not work as you would intend for it to work. Never use keywords as names for functions, variables, or other objects. After the def keyword, we have the name of the function, and then parentheses enclosing any arguments. The body is indented. And Python frequently uses white space as a delimiter of contexts. We'll see this pattern repeated again later in this notebook. For the sake of functions, any indented code following the function definition is part of the function body. And the function body ends once we encounter code that is not indented. Functions also halt execution after a return statement. Therefore, any code after a return will not execute. Since the indentation shows the extent of a function body, we can designate the end of a function by having unindented code. So for example, here are two functions, example A and example B. When we define and evaluate or call example A, we'll see example A is running and returning value A, followed by the returned value A. So these were printed to screen, and then we have the returned value A as output. This will not execute, never got printed to screen, because the function had already exited due to the return statement. Example B prints out example B is running and then exiting without returning a value. The function still exits because it has reached the end of the function body. The function body is ended because there's no more indented code under the function definition. This concludes our discussion of functions and Python function defining syntax. In the next video, we'll be talking about conditionals and logic, which will allow us to make decisions in our program based on the state of different variables or user input.